I don't mean to imply that there's anything special about this name, E. That's just the name that I happen to choose for the parameter for the catch block. But of course you could choose some name other than E. Slide 6 repeats things that I've said as we discussed slide 5. The catch blocks are examined in order from top to bottom, and the first one that matches is executed. Any trailing ones are then skipped over. And then following the sequence of catch blocks, whether one is executed or not, execution simply continues with whatever the next statement is following all of the catch blocks. Okay, so here on slides 7 and 8, we have a small program illustrating these two problems that we've just talked about, namely the bad ALEC problem or the out of range problem. We've included new and we've included standard except so that we know about the bad ALEC class and the out of range class. Those are the two kinds of exceptions that we're looking for. Okay, so in main, we have a for loop that's going to go for 1,000 iterations, and inside the for loop we have a try block. The try block starts just as we enter the for loop for the current iteration, and the try block ends at this point here on slide 8, and we have two catch blocks following the try block, and below the catch blocks we have a cout statement and the curly brace that concludes the for loop. Alright, so let's see what this program is doing here. So for the first time through the loop, we're going to try this switch statement. Switch is going to invoke the rand function. We're going to get the remainder after division by 5. So that means we're going to have some value, 0, 1, 2, 3, or 4, within the switch. If the value happens to be 0, which ought to occur approximately 1 time out of 5, then we're going to attempt to allocate 1,000 arrays of 1 billion long doubles. And that is simply not going to work. That's going to throw a bad ALEC exception. So we pop out of the switch as a consequence of that throw. And here is the catch block that is waiting to see whether a bad ALEC exception occurred. Sure enough, it did. And so if we get a bad ALEC, rather than crashing, the program is simply going to display this message, caught bad ALEC. And then we will display this cout message, we are here, I is 0. And we'll go back to the second iteration through the loop. Okay, so in the second iteration of the loop, we pull another rand value between 0 and 4. Let's suppose this time the value happens to be 1. Here's case 1 at the top of slide 8. We have a vector containing 5 values, and notice that we're going to use at with a random index here between 0 and 5. Now, very roughly speaking, we're going to get a uniform distribution of values between 0 and 5 from this calculation, and that means that 5 times out of 6, if we have an index between 0 and 4, v.at of the index will be fine. We'll simply display the value at that index. Then we'll come down below the catch blocks and we'll say we are here, I is whatever it is, and we'll go back up to the next iteration of the loop. Now, unfortunately, approximately 1 time out of 6, we're going to end up here with an index of 5, and of course an index of 5 is out of range, and that's going to throw an out of range error. We'll find ourselves in this catch block, and we'll display the message caught out of range. Because we have this catch block, the program does not crash. We say we are here, I is whatever it is, and we go back to the for loop. So the for loop is going to run 1,000 times. We have two possible exceptions that can occur, namely a bad ALEC or an out of range. And because we have catch blocks set up for both of those, this program never crashes, but it probably will spew out these caught bad ALEC and caught out of range messages on a fairly regular basis. In fact, here's the output of one test run on slide 9. In fact, this is just the first 14 times through the loop. And of course, if you run this program, it may behave differently for you depending on which value your rand function starts with. Okay, so the first time through the loop in this example, no exception occurred. We got through the try block without generating an exception. That means we just fall through the catch blocks, and we get to the cout statement, which simply displays we are here, I is 0. The second time through the for loop, apparently in the switch, we got a case 1, which means that we're in this vector accessing part of the code. And also, we were unlucky enough to draw an index of 5, which is out of range, and so the @ threw an exception, and we come down here to display caught out of range. After we display caught out of range, we drop down to the black cout statement, and we display we are here, I is 1. Now, generating out of range, and therefore catching out of range, is a rare event. We only get into the vector code once in every 5 iterations through the loop, and even when we're in the vector code, we only throw an exception 1 time out of 6. So roughly speaking, 1 time out of 30 through the for loop, we should generate and catch an out of range exception. Okay, the third time through the for loop, we don't cause any exception. We just get told we are here, I is 2. The fourth time through, the same thing. The fifth time through, in the switch expression, we evidently get a 0, and so this generates a bad ALEC exception. That gets caught in the first catch block, and we display caught bad ALEC. And after we've displayed caught bad ALEC, we fall down to the black cout statement, and we display we are here, I is 4. Okay, so remember that i's value is always 1 behind the actual iteration through the loop. So we just finished the 5th iteration through the loop. Now, in the 6th iteration through the loop, apparently rand mod 5 is a 1, so we come down into this vector code, and in the @ function call, rand mod 6 is apparently 1, because v.at1 is this 2, and it's that 2 that's being displayed here. So we have a successful access of one of the vector elements in this case. There's no exception displayed, and we come down to the black cout, which tells us we are here, I is 5. And this continues in the same vein. Apparently we access the vector twice more successfully. We see another blue 5, and we are here, I is 6. We see yet another blue 5, we are here, I is 7, and so on and so forth. And this continues for 1,000 iterations. Now, when an exception occurs, we would certainly like to know a little more than that it was a bad ALEC exception or that it was an out-of-range exception. One way we can find out a little more about what occurred is through the use of the what member function that's provided as a virtual function in the exception base class. So the what member function returns a C-style string. That is, it returns a pointer to the first char in a sequence of chars terminated with a null char. And the derived exception classes, such as bad ALEC and out of range, provide overrides for what that give messages that make sense for that particular kind of exception. Now, when I say they make sense, I don't mean they're necessarily really easy to read. For example, here we have a try block. We are creating v as a vector of int initialized with 3 elements, and we're saying v.at7, which of course is out of range. So that's going to throw an out of range exception. Immediately below the try block we have our catch exception, and that out of range exception we're going to be able to access through this reference parameter e. We can invoke e.what to find out more details about this particular out of range, and what we get, at least on my system using GNU C++, is in the vector class mRangeCheck, that is, we're checking the subscript, n, the subscript, is 7, and that's greater than or equal to the size of the vector, which is 3. So in a nutshell, that tells us that we tried to use an index of 7 in a vector that only contained 3 elements. This is nice. It tells us what the problem was. Unfortunately, it doesn't tell us anything about where the problem occurred, so there's more information that we would also like.